Half the battle in this question is getting a good diagram down. So I just drew a trapezium, made these two parallel, called it PQRS. But then I ran into difficulties because it says RSP is meant to be 120, but here I've got an acute angle, and then PS is meant to equal SR, and it's meant to be a third of PQ. So I've not labeled it correctly, or equivalently, I've not kind of put the trapezium in the right orientation. I could put it upside down, and then it would work, but actually I'm just going to change the labeling. So I'm going to say that this is P, this is Q, this is R, and this is S. So now I'm going to have 160s here, 120 here, sorry, which is much better. And when you have co-interior angles, parallel lines that kind of meet in the C, these two add to 180. So this angle is going to be 60. You could do it the other way around if I labeled it PQRS, but I've gone with the left-hand side being 60 and 120. Right, so let's draw this a little bit more accurately. Okay, so I've got this length here, and it's going to be coming down about 120. I can, just by eye try and get it right, and it's the same length. And then it's like three along. So I've got that bit, and then another one. So maybe something like that. Maybe I'm exaggerating it, but that's not bad. Okay, so I've got 120 here and 60 here, as I said, and then P, Q, R, S. Right, I'm going to label PS equal to SR. That's that bit sorted. And I've also dealt with the angle. I've dealt with the fact that they're parallel. I've not, no, I haven't written that on yet. They're parallel. Right, the one thing I've not done is use the fact that actually these two sides are a third of PQ. Okay, so what that means is that I could basically take SR and I could just kind of draw it along here like 3 times. And that is actually essential for this question, because what we can do now is connect it up into some triangles. There we go. And here's the thing, because I've got now these two are equal, it must be that I've got an isosceles triangle and these two angles are equal, and they're actually going to be 60. I'm turning this into equilateral triangles. Because this is 120, this will also be 60. And then because this length is the same as those three, this is also an isosceles triangle, in fact, another equilateral triangle. So they're all 60 as well, which means that length is also, they're all equal as well. And then this length down here is the same, this one in green. So this is going to have to be 60 because I've got 180 overall, and therefore this is 60 and this is 60. And this, this takes a little bit of time to figure out, I think, but this is a construction. Actually, the trapezium is necessarily made out of 3 equilateral triangles and then 1 triangle at the end. But there's something we know about that one, and it's going to be isosceles. Those two lengths are also going to be the same. Remember, we used 3 of the SRs, like I kind of just, I've just depicted them, and then I've shown that all these lengths are the same, so these two must also be the same. Right, and remember, what we're actually trying to find, PQR, this angle here. Okay, well, this angle is 120 because they're on a straight line, and therefore I've just got my kind of standard isosceles triangle problem, 120 here, 2 side lengths here. So I need to share out 60 between 2 angles that are exactly the same. It's just going to be 60 divided by 2, which is 30. So this angle is 30 and this angle is 30. Our answer is D. Brilliant.